This is question 20 from the Midsem exam. It's a slightly tricky one. I've gone through and pulled out the equations we're going to need here. This is the mean time to failure, which is the RPFT, or the reliability of the system, integrated over the whole region, or the whole scope from 0 to infinity. And to find that, we're going to need 1 minus the product of all of these. And if you're wondering why this is the way it is, I'm just going to scoop across to a new page for a second. And if we're looking for the case where we've got a parallel system here, let's draw one out, then the only way that this system fails is if both A fail and B fail. So I'm going to denote fail being like that, and not is going to be a little hat. So if we start with the possibilities that A is going to fail or not fail, and then we go out, B is either going to fail or not fail depending on what happens with A, not depending on, just listing out all the possibilities that might happen. Now, of these, the only way that this can possibly fail, this system, is if A fails, so this one, A fails, and also B fails. So just remembering, if we wanted to find that particular, the probability of that whole thing happening, we need the probability of the first part multiplied by the probability that the second thing happens. So we need probability of A multiplied by probability of B, and that gives you that. Now, for this system to fail, that is the probability that this system is going to fail. Now, we don't want the probability that it's going to fail, we want the reliability of the system. But to find the reliability of the system, what we do is we take the probability that it's going to fail as a function of time, which is what we're going to get in a minute, and take that whole thing away from 1. That's going to give us the reliability that this is not going to happen. Hope that makes sense and doesn't get too confusing. It's certainly been a confusing learning progress for me to get to that point. And within our reliabilities, as you'll see in a second, what we actually do is, instead of saying the probability of failure, we're taking the reliability, because it's a reliability function that we've got. So hope that makes sense. I'll explain in a minute a bit more. So let's try and find the reliability for our system. The other thing we're going to need is the reliability of an exponential is e to the minus lambda t, and we're also given the mean in here, and we want lambda to put into this equation. This one, by the way, if you forget, is number 45 in our equation sheet. Now, lambda is equal to 1 over mu, and we're given mu, so we'll be able to calculate those very easily. Equals, and that's, I think, equation 46 in the equation sheet. So we've got enough there to calculate everything that we need, and we're just going to have to grind through a little bit of maths to do it. So let's find first the system reliability, and that is going to be equal to 1 minus, now we need 1 minus the reliability of the first one, of system A, of component A, 1 minus, and the reliability is given by this, so that's 1 minus e to the minus lambda A t A, and that's multiplied by 1 minus e to the minus lambda b t. I'm not putting those in yet because it gets fiddly to write a lot of fractions all over the place. So bearing in mind that what we actually want is the integral of that thing, and in the interests of saving space, what I'm going to do is convert this into an integral. So we want mean time to failure of the system is going to be given by the integral from 0 to infinity of that thing with respect to time. And then what we're going to need to do is expand out these brackets. Now these brackets always expand out in exactly the same way, so I reckon it's worth remembering this. That is the same thing as, and this is going to be e to the lambda 1, I'm going to call these 1 and 2 because writing a and b is too hard, to the minus lambda 1t plus e to the minus lambda 2t minus e to the minus lambda 1 plus lambda 2 t dt. That always works out the same. I know you can work that out fairly comfortably if you just expand it out, but in an exam situation it's easy to mess it up, so I've memorized that. Yeah. So let's go ahead and do the integration here. We've got, it's going to be equal to what's one, I mean the lambdas are all fractions here, so it's actually going to be the mean multiplied at the front. Maybe we should just write the whole thing out a little bit to avoid losing myself again later when I try and rewatch this video. So this is going to be the same thing as minus 1 on 7.2t plus e to the minus 1 on 4.2t. I think this is wrong, this is 7.1, minus e to the minus 1 on 7.1 plus 1 on 4.2t plus, there's the whole thing, dt. So bringing it all over here is equal to, let's get our big bracket out. So now we're going to be multiplying by that, so we just bring it out in front. It's going to be equal to minus 7.1 e to the minus 1 on 7.1t plus, minus 4.2 e to the minus 1 on 4.2t, and then this is going to be plus. If you've forgotten how to integrate these so easily, try differentiating what I've just done. Putting a fraction down the bottom is really, I'm just flipping it over. Plus e to the minus, plus, let's see, 1 over that whole thing, 1 on 7.1 plus 1 on 4.2. E to the minus 1 on 7.1 plus 1 on 4.2 t. And that's from 0 to infinity. Thankfully most of this just goes away, so the actual calculating bit you don't even need a calculator for. Why is that? Because we've got negatives in all of the exponents, so that means when we're trying to take the first bit, the infinity part, we end up with minus 0 plus 0. Tricky. So this is minus 7.1 divided by e to the infinity, essentially. And they're all e to the infinity on the denominator, so that just goes away. Minus, these ones do not go away. So now we've got e to the zeros, so all of the e parts go to 1 because it's e to the 0, and then the front parts get brought down. So it's 7.1 minus 4.2 plus that whole ugly thing again, 1 over 1 on 7.1 plus 1 on 4.2. And this is going to be our answer, just remembering that we can actually, this is all going to vanish, and this is going to be, it's going to be gone, and this is going to be plus 7.1 plus 4.2 and minus, shouldn't have done that, 4.2 and minus that thing, and you'll see that that compensate does come up with our answer of 8.66. So that was a long video. Hopefully that helped a bit. If anyone's got a simpler way of doing that question, I'd love to hear it. Otherwise, yeah, you have to churn through some integration.